Have y'all ever heard of quadrants from geometry? Yes? Do y'all remember where quadrant 1 is?
Top right.
Good. And quadrants are separated by x and y axes. And if you think about the circle we talked about, it goes in counterclockwise position. So quadrant 2 will be where? Good. Quadrant 3. Very good. And quadrant 4. Alright. Now let's talk about this poster first, this all silly trig classes. We know the different trig functions, cosine, sine, and tangent, right? Each quadrant, the trig functions are either negative or positive, depending on their position. Okay, and here's the reason why. If I were to draw a triangle right here, go ahead and draw this triangle. Remember we talked about yesterday that the angle we're always looking at is from here. The opposite of this angle would be your y, right? Adjacent would be your x, just like yesterday when they gave us a coordinate point. And what would be, if this was your opposite side, wouldn't this be a positive y value? And this would be a, yeah, all the x values on this side are positive, right? 1, 2, 3, 4. So both of these are positive, correct? So tangent, which is opposite over adjacent, would be a positive over a positive, and that would be positive as well, right? So all of the trig functions are positive here. You can put all. In quadrant 1, all of them are positive. Cosine, sine, tangent, and also their partners, cosecant, secant, and cotangent. Now, if I drew a triangle on this side, would the y still be positive? Yes, it's still going up, but the adjacent this time is what? Negative. So which one is negative? Which deals with which trig function? Tangent and cosine. Good. So the only one that's positive is going to be what? Sine. Good. You can put silly right here. And the reason I put silly starts with the letter S. The only one positive is sine. And its partner, which is what? Cosecant, CSC. Okay? If I drew a triangle here, which one is positive, my y or my x? Neither. Good. This one's negative, and this one's negative. So sine and cosine will both be negative, but tangent, if you have a negative over a negative, would make what? Positive. So you can put trig. The reason I put trig is because the all silly trig classes is just an easy way to remember it. But whatever letter it starts with, trig, that means tangent's going to be positive and cotangent. Good.
Wait, okay.
And then this one right here, if I drew a triangle, would my y be positive? So sine is negative. Which one's positive? Which is cosine. Good. You can put classes right here. And then if sine is negative and cosine's positive, if you divide them, a negative and positive, you'll get a negative, right? So the only one that's positive here is cosine and secant. Good. Do I need to write those? Okay. So right here, all of them, so I'm not going to write all of those, but here it'd be sine and what? Good. Cosecant. Right here it would be tan and cotangent. Right here it would be good and secant. So without the poster, just remember all silly trig classes and you look at the first letter. First quadrant, everything's positive. Easy enough?
I don't get it. I mean, I get it, but I don't understand.
I was going to say, like, the...
Oh, we'll use it in a second. Right now we're just working on, like, memorizing it. We'll work on what it means in a second. Okay, so reference angles is what we're talking about. We need to write the definition out, and that's going to be positive acute. Anybody remember what acute means?
It's where like it's less than 90 degrees.
Good. Less than, let's put or equal to 90 degrees. In parentheses, just to remember. So reference angles have to be less than or equal to 90. and they're always positive, and they represent an angle of any measure. Alright, so if I said the reference angle for 60 degrees, it would just be itself, 60 degrees, because it's acute. But if we have one that's in quadrant 2, and somebody give me any degrees in quadrant 2. 20 would be in quadrant 1. Quadrant 2 is this quadrant, right? So it's got to be from 90 to 180. 135. Okay, so quadrant 2, here's an example of one that would be in quadrant 2. Anything between 180 and 90, correct? Or 90, 180. So to find this reference angle, if it's in quadrant 2, here's the formula. You'll do 180 minus, and I'm going to put theta, and theta just means whatever angle you're given. So if we wanted to find the reference angle for 135, we just do 180 minus 135. Okay? That's if it's in quadrant 2. I'm going to just put over here quadrant 1, you can just write this itself, because everything in quadrant 1 is going to be an acute angle anyways, right? Alright, if it's in quadrant 3, somebody give me an example of any measure in quadrant 3. 190, good, because it's between 180 and what? 270, so 190 would work. So to find the reference angle for any measure in quadrant 3, you would do theta minus 180. So for example, you could do 190 minus 180 to find its reference angle. Alright, last one would be quadrant 4. And give me an example of something in quadrant 4. Okay, so for 300 degrees, if anything is in quadrant 4, you would take 360 and subtract from whatever that angle measure is.
What are you getting to measure?
The 135, 190, 300, they're just spitting out random angles. Alright, so for 1 through 12, we're not getting anything too heavy right now. We're just finding the reference angles. So we're going to be using these formulas, okay? So for this first one, 240, what quadrant is 240 in? Good. And do I need to label these again? This is 0 what? This one is? This one?
270.
So where would 240 be? In between this, right? So put Q3 up under it. So if it's in Q3, how do we find its reference angle? Good. And this time theta is what? So what is 240 minus 180? 60 degrees. Good. That is 240's reference angle. It's an acute angle because it's less than or equal to 90, and it represents that angle measure. Alright, number 2 is a little different because it's in radian. Y'all remember how to turn that to degrees? Good. You multiply 2 times what? And divide by 3. Tell me what you're going to get. Did everybody get 120? Alright, so where is 120? Is it Q1, Q2, Q3, Q4? Very good. Q2. Because it's in between 90 and 180. And so if it's in Q2, we're going to take 180 minus what? 120 and get what? Good. 180 minus 120. So its reference angle is also 60.
Are you always going to multiply it by 180?
Yep, pi is always 180.
Okay.
So in number 3, we have to do 5 times 180 divided by 4. Tell me what you get. 225 degrees. What quadrant is that in? 3. Good. So to find its reference angle, we do what? Good. And that's going to give us what? 45 degrees is its reference angle. Questions about that part? Alright, let's do about 3 more together. Any specific ones y'all want to do, or it doesn't matter? 12, 10, and 7. Okay. So let's look at 7. This one's a negative degrees. We want to get it to a positive degree. So how do we find its positive coterminal angle? Y'all remember that?
So you go the opposite way.
So you would do what to figure out where it stops? Good. Add 360. Remember, for a coterminal, you add or subtract 360?
Wait, can you explain all of that?
Yeah. For coterminal angles, they're in the same position, just different angles. So to find out where this stops, because you're going to be going backwards, you just add 360. So add a circle to make it positive. That makes what? 245. And where's 245 at? Quadrant 3. So we're going to do what to find its reference angle? Good. And tell me what the reference angle would be?
65.
Good.
Why did you subtract 180?
Because it was in quadrant 3. So if you look up here in quadrant 3 to find the reference angle, you just take whatever that angle is and subtract 180. Any other questions on that one?
So anytime you got like a negative, you got to add to 360.
Yep. And if it was like 420 degrees, you would
Add
not add 360.
Subtract it.
Yeah. So if it's greater than 160, you subtract 360. If it's less than or a negative number, you add 360.
So you said if it's greater than 360.
Yeah, like 420, 510, 620. All right, number 10, you're going to have to do negative 5 times 180 divided by 6. Anybody find that yet?
Negative 150.
All right, negative 150. So again, this is negative, so we need to do what with it? Add 360, and that's going to give us what? 210. 210 is in what quadrant? 3. So we would take 210 and do what? Good, and get 30 degrees. Good. Any questions on that one? Okay, one more. Go ahead and tell me what 3 pi over 4 is going to give us. Negative what?
negative 135.
All right, so we need to do what? And get 225, which is in quadrant what? So we do 225 minus 180 and give us 45 degrees. Good. All right, try 4, 5, 6, 8, 9, 11 on your own. I'm going to call on different people to give me the final answer, the reference angle. If you're having trouble, you can ask people around you. You can ask me. All the rest of them up here that we didn't do together. So that would give us what? So this is something that's positive 135. So now 135 is in which quadrant? Okay. So you do Alright, we'll start going over these together. You may want to help me with number 4.
That's 60.
Alright, how'd you get that?
Again, 360 minus
What quadrant is this in? Because this is in quadrant what? 2. So we would take 180 minus 120 and get what? Good.
But how would you know what quadrant it is?
You just look at 120, and this is 90 to 180, so we know it has to be in between here because 120 is in between 90 and 180.
I did it differently, but I ended up getting the same.
Okay. So what'd you do for this one?
I did it.
Okay.
Wait, you talking about number 4?
Yeah. No, number 5.
Oh, no, I did it.
And why'd you pick 360 minus 315? Because it's in quadrant what? Good. So we would use this formula. What'd y'all get? Very good. Alright, what is number 6? What is that angle? 150? That's in quadrant what? So we would do and get, very good. Questions about those? Okay, what about this one? What is this degree? Negative 225. If it's negative, we know we need to do what first? And get what? 135 is in quadrant 2, so we would do and get 45 degrees. Very good. And 330, we can just do what? And get, good. And last one, 210 degrees is in what quadrant? 3, so we need to do what? And that gives us, good. Alright, how do we feel about finding reference angles? Good? Yes.
How do we know, like, say, for number 11, you did 210 minus 180.
Mm-hmm.
How do you know, like, not to do forgot what I was
Like add 360?
No, I was doing like the subtraction wrong. Like I was subtracting like 210 from 270.
Okay. You can only use 180 and 360 when you're doing reference angles. Can't do 270. So anytime you're doing reference angle, remember you just have to use 180 and 360. Only these two. You can't use these two. Okay. And what'd you get when you did? You got 60? Okay. Any other questions on these? Okay, so what are the common, what do you see a pattern in these problems? What angles appear the most?
45, 60, 30.
Good. These up here are called special angles, but really they're not really special because you see them all the time in trig. 30, 45, 60, 90, and 0 degrees you see all the time. And those are all in quadrant 1, correct? So what we're going to do is, for pre-cal and for this class, you're going to have to memorize all the 6 trig functions for 45, 60, 30 degrees, 0, and 90. And I have a really cool trick to show you. I'm really excited. First, let's label these. What is 180 divided by 6? Okay, 30 degrees. This one's going to be 45. This one's going to be 60. Alright, same thing over here. And I'm going to show you how to memorize these. Alright, I've drawn a hand up on the board. And I'm going to use this hand. Actually, I'm going to use this hand. My right hand. Alright, what you need to remember is on your hand that this is 0. And then the next smallest degree we're talking about is 30, right? And then 45, and then 60, sorry, my fourth finger, and then 90. Again, 0, 35, 45, 60, 90. It goes in order. All you need to remember is what each finger is. Okay, so what's my third finger? What's my pinky? 90. What's my thumb? Fourth finger? This one? Good. Okay, so once you memorize that, now you just have to remember that this, your thumb is always sine. This is cosine. Okay? So here's how we do it. The first one is 30 degrees, right? Have your hand out. Which one's 30? My pointer finger. Put it down. Alright, this side is sine. And how many fingers do you see?
4.
No, this side. 1. Right? Now on this side of my nub, how many do you see? And that goes with cosine, right? So now the only thing we have to do with these fingers is whatever you have, however many fingers you have left, you have to take the square root of. That's why I have a square root in my palm. So square root of 1 is what? 1. And now just put it over 2. So square root of 1 is 1. Now just put it over 2 and you get what? Good. Put 1/2 right here. So again, whatever the angle is, you put that finger down. This side's always sine. This side's always cosine. So however many fingers you have on this side, which is 1, right? You just take the square root of whatever this is and put it over 2. Same thing here. There's 3 fingers left. So you take square root of 3, which we can't, so we'll leave it as square root of 3. And the bottom will always be 2. I'll say it one more time. However many fingers, you take the square root, put it over 2. So this will be square root of 1, which is 1 over 2. This will be square root of 3 over 2. That's cosine. The more we do it, the more you'll have it memorized, okay? And now, just to review, don't write this part down. But sine is what? Opposite over hypotenuse, correct? Don't write this part down. I'm going to just write it right here. Cosine is? Good. And tan is? Good. So what is our opposite? Just 1. What's our adjacent? Good. So tan would be? Good. And now let's just simplify that by multiplying both of them by square root of 3. Right? So we would have what?
Square root of 3.
Very good. Alright. Now I'll show you how to check them in the calculator. And you can do these in your calculator, but here's the problem. Let me show you what sine of 30 would look like.
Wait, what?
You can check it in your calculator. So let me go back. Sine of 30, which is what we just calculated, 1/2, right? You can just type in sine of 30. And it'll give you 1/2. So you don't have to use the finger trick on that one. But then if you type in cosine of 30, it's going to give you that. 0.866, blah, blah, blah. And I want it as a fraction, right? So how would you know that this is square root of 3 over 2? You wouldn't unless you do the hand trick. But you can check it by typing in square root of 3 divided by 2. And see it comes out to be the same thing.
Go ahead, Counsel.
Oh,
Go ahead.
okay. Does that make sense? Alright, so you can check it, and some of them you can type in your calculator, but some of them you'll get a decimal, and you don't know what that is as a fraction, unless you're a genius and you just memorized all the square roots. Okay, let's try it with 45. So take your hand out. Which one is 45? Alright, put it down. Which side is sine, thumb or pinky? The thumb. So how many fingers are on this side of my nub? 2, right? 2 fingers. So it would be square root of 2. No, let's go back. You take the square root of this, so square root of 2, right? And it's going to be over 2. Very good. Square root of 2 over 2.
How do you know it's over 2?
You always put it over 2.
Okay.
Alright, now let's do it for cosine. So that's this side. How many fingers are on this side of my nub? So it'd be square root of 2 over 2. Again, this is opposite over hypotenuse, adjacent over hypotenuse.
Hypotenuse is always 3.
Yes, always. So now we'd have square root of 2 over square root of 2, right? Opposite over adjacent, which would give us what? I wish somebody would have taught me this when I was in school. I just had to memorize it. All right.
I'm gonna come back. I get a headache.
Oh, okay.
Look.
I'll come find you during lunch. Is that okay?
Yeah.
Okay. All right. 60 degrees is what finger?
The ring finger.
Yep. Okay. So this side is sine. How many fingers do I have?
3.
So it'd be square root of 3 over 2. Good. I told you I would like this. What about cosine? Square root of 1, which is 1 over, good, so 1/2. Anybody can tell me what tangent would be?
Square root of 3 over just square root of 3.
Yep. How about that? That was this poster. We're not done yet. We just have to find the other 3, but the other 3 are just flipping, right? You just have to flip your values. So for sine, this would be what? Or cosecant. Just 2. This one?
2, 3, 3.
We'll write it like this first. Alright, now we have to multiply both by what? Just square root of 3. So the top would be over 3. Very good. This one? Let's flip it. Yeah, 3 over square root of 3. Now we have to multiply by square root of 3. We get what on top?
3 square root of 3 over 3.
So that's just 1 what? Yeah, and we could have done it from here. We could have flipped this part, and you just got square root of 3 over 1 to save some time, but that's okay. Alright, this one? Be 2 over square root of 2. So multiply both by square root of 2, and we'll get what? 2 square root of 2 over, which is just, good. Sorry, I'm running out of room. So cosecant of 45 is just square root of 2. And this one's the same, isn't it? So let's save ourselves some trouble and just write square root of 2. Got it from here. This one? Still 1. This one will be 2 over square root of 3. So multiply both by square root of 3. We'll have what?
2 square root of 3 over 3.
Very good. Swap this one. Swap this one will be 1 over square root of 3. So multiplying both by square root of 3, we would get, very good. Alright, do I need to go over the hand trick anymore, or y'all understand it? One more time? Okay, don't look at your paper then. Alright, tell me what, and we'll do it on your own. Alright, tell me what, don't look at this paper either, okay? I'm going to take it down.
I don't even understand.
Tell me, it's on the board too. Tell me cosine of 60. Try not to cheat. Cosine of 60.
That would be like,
Square root of 3 over 2.
1/2. Good.
what is cosine on it?
Alright. Cosine is pinky side, right? 60 is which one? Huh? Ring finger? So this side is cosine. So this is square root of 1, which is 1 over 2. So 1/2. Alright, tell
How do you
me.
know which side you're? So this side is cosine.
You square root your fingers.
So,
And then put it over 2 always. Yes.
so this side over here is cosine.
Cosine, sine.
About
Sine,
tan.
cosine. Tangent is going to be sine over cosine. So, for example, I know, I'm not going to tell you that. You can just get that from the
Oh,
chart.
yeah, okay. Yeah, sorry.
But I'll show you if you wanted to just use your fingers. Tan is just sine over cosine, opposite over adjacent. So, for example, if you wanted to do tan of 45, you could do square root of 2 over square root of 2, which is just 1. Okay. Fingers are getting cramped up. All right. Sine of 30. Which finger? Good. Sine is which side? So it'd be 1 over 2. 1/2. All right.
It's 1 over 2 from that.
From here, this side's your cosine. So there's how many fingers next to my nub?
3. Or 1.
Just 1. So square root of 1
1.
over 2, which is 1/2.
Okay.
All right. Cosine of 30. Which finger?
Pinky.
Cosine of 30. Good. So it'd be square root of 3 over 2. All right. Let's move on. So what about 0 and 90? Our thumb and our pinky. That's what we're going to talk about. So what about angles on the axes, which are what right here? And right here? And right here? And right here. So what about if we had sine of 0 or sine of 90? So we can't use 180 and 270. They aren't on our fingers, right? But 270 is going to go with what it's across from. So 90 and 270 will give you the same. And just like that, 0 and 180 will also give you the same value. So let's look at sine of 0 degrees to start with. Alright, which one is 0? Do y'all remember? Your thumb. Okay, put it down. Now sine is on this side, right? What is on this side? 0. Nothing is on this side of my nub, right? I'm trying to make a nub. So this would be 0. Square root of 0 is 0 over 2. So it'd be what? 0. Sine of 0 is 0. Let's look at cosine of 0 degrees. Same thumb, right? This time I'm looking at this side, my pinky side, and that's what?
4.
What's the square root of 4? And you put it over 2 and you would get 1. Let's try cosine of 270. Again, we don't have 270, but we know it's the same thing as what? 90. Which one's 90?
Pinky.
Alright, so cosine's on this side. What is there?
Nothing.
So it'll be 0. Alright, sine of 90. Again, it's this one, right? 90. How many are on this side, my thumb side?
3.
4.
Uh-oh.
So square root of 4 is over 2. Very good. Alright. We'll practice the hand trick some more on the back. Flip it over. So now that we are good with reference angles, and we've kind of memorized this part, we are going to use it to find the exact value of all of these. With no calculator, just your hand. Alright, first step, and it kind of got cut off, we're first going to have to find the reference angle. That's what we have been doing on the front, okay? So ignore the cosine. The 120 is in what quadrant? 2. So 180 minus 120, that's going to give us what? 60 degrees. So we are finding cosine of 60 degrees. And this is where we can use our hand, okay? Try to tell me what cosine of 60 is using your hand. Very good. Do I need to show how we got that?
Yes.
Okay. 60 is which finger? Ring finger. And again, cosine's on what side? Thumb or pinky? Pinky. So there's one finger right here. So it would be square root of 1, which is what?
1.
Over 2? 1/2. Now, the only thing is, we have to figure out if it's going to be negative 1/2. And the way we do that is we use all silly trig classes. That's why we learned it. So in quadrant 2, which trig function is positive? All silly, right? So just sine. So this one's going to be negative 1/2. Now if you want to check it, you just do cosine of 120 in your calculator, negative 1/2.
Wait, I thought that was all positive.
Nope, in quadrant 2, it's all silly. Silly's in quadrant 2, so it's
Oh,
sine and
okay.
cosecant. Alright. Get that in a second. What now?
thought we were doing cosine.
We are. So think about in quadrant 2, which ones are positive and negative. So in quadrant 1, all of them are positive, right? And this one only sine and cosecant, right? That's why this is negative. Because it's in quadrant 2 and it's cosine. So it's negative. This one's going to be tan and cotangent. Cosine is tan. Alright, let's try another one. Sine of 315. This is in what quadrant? So Q4, we'd have to do 360 minus 315. That's going to give us what? Alright, let's find 45, sine of 45. It's square root of 2 over 2, because you put your middle finger down, right? Square root of 2 over 2. Only thing is, we just got to check the sign now. And what do we use to check the sign? Whatever quadrant it's in, right? This is in quadrant what? 4. So what's positive in quadrant 4? Good. So this needs to be very good. Alright, tan of 210. 210's in what quadrant? 3. So we need to do 210 minus 180. That's going to give us what? 30 degrees. Alright, remember tan is the same thing as sine over cosine, so you can still use your hand for it. 30 is which finger? Alright, and this is sine, right? So this will be on top. So what's the square root of 1? Alright, that's our numerator. And then over here will be square root of 3. That's our denominator. So now we need to fix it and do what? Multiply by what? Good. So on top we will get on bottom. And now last thing we need to check. This is in quadrant 3. What's positive in quadrant 3? So this needs to be positive. It's in quadrant 3 and it's tan. So we know it'll be positive. Alright, how's this going so far?
How would it be negative if like all the rest of us positive?
This one's in quadrant 3. That's this one right here, right? So the only ones positive in quadrant 3 are tan and cotangent. Everything else is negative.
I said I know that, so like how do you know that it become negative? I'm not question is
How to use the all silly trig classes. All silly trig classes. Now whatever this starts with is what functions will be positive. Right here all of them are positive. Right here only sine, right here only tangent, right here only cosine. Alright. Next one is sine of 90. Do we know what quadrant this is in? It's on the axis, right? Hmm?
Is it itself?
What do you mean?
Like on the front, on the itself. This one.
Oh, it's not in quadrant 1 or quadrant 2, right? It's the top, it's the axis. So we don't know what quadrant it's in yet. But let's go ahead and find sine of 90. Which finger is that? Pinky. So I have square root of 4, which is over 2, which is 1. Very good. And now the easiest way to remember this, first let me draw a picture. You don't have to draw this. Sine is our y, correct? So if we drew a triangle right here, would this be positive or negative, this y? Going to 90, it'd be positive, good. If you want to check it, you could type it in your calculator.
So the answer is positive 1.
Yes. Alright, we're going to do 2 more. 2 pi over 3 is what degrees? Hmm? 120. That's in quadrant what? So to find the reference angle, 180 minus 120, that's going to give us what? Alright, find sine of 60 with your fingers and tell me what you get. Very good. And what about in quadrant 2? What's positive? Sine. So we can leave it positive. One more. Let's look at number 17. Alright, 270 is where? On it, right? Okay, so let's go ahead, but what does this go with? 90 degrees. So we are going to find what of 90? How we do that? We first got to find what? Yeah, sine of 90. We found that one in number 4. What did we get? 1. So what would cosecant of 270 be? Think about sine is 1, right? Or 1 over 1? Quit guessing. 1 is the same thing as 1 over 1. Cosecant is flipping it, right? It'd just be 1. Now the only thing you have to check, is it negative or positive? At 270, what would my y be doing? Negative. Very good. Your homework is the rest of this worksheet. I'll be checking it on Friday.